Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we're going to learn lesson number 36, part 1. And one of the reasons why it's split up into two parts is because basically there's two kinds of sequences that you need to know. And yes, this is a relatively hard lesson compared to the one before it. And the first section I dedicated to arithmetic sequences. The second section I dedicated to geometric. Of the two, the one that's latter is a bit more difficult than the former. After that, we're going to do lesson 37, which is called the binomial theorem, and that's going to be the end of sequences. So it's a small subject that we learn, and we're going to continue after that with a few other topics, inshallah. But as you can see, the end of the course is in sight. All right. So let's get started. One of the things that I spoke to you about in the last class is factorials, and I'd like to just kind of highlight for you a few things about factorials. Recall that a factorial, basically, you had to take the number, right? You had to take the number n and then multiply it to the number that's 1 less than it, then 1 less than that, and you keep going until 1. So that is called the abstract way of looking at it, okay? Now, there's a few rules that I basically just forgot to mention to you, and just so much going on. So 0 factorial is 1, and 1 factorial is 1. Okay, so those are a few things I wanted to mention, especially that second one right there. That's not very intuitive, right? It doesn't just come to you right away. Okay, so today what we're going to do is we're going to first begin with some formulas. Okay, so in these formulas, the first one is called the common difference formula, and it's specific to arithmetic sequences. The second one is called the common ratio formula, and it's specific to geometric sequences. So the moment that you hear common difference, it automatically is referring to arithmetic sequences. The moment that you hear common ratio, likewise, it's referring to geometric sequences. Now, along with that, you basically need to list out a certain amount of numbers, okay, and then figure out what's the pattern as you're going forward. And the specific way, I will refer back to this eventually, right? The specific way of doing that is to basically follow this formula. Now, based on your understanding of that previous lesson, you understand that when somebody says a sub n, that just simply means a term. But when they say a sub n minus 1, that means the term that came before it. So it's telling you to take the latter term and subtract the former term is really what it's trying to refer to over here, right? Then on this end, okay, on this end, that one is rather different. It's telling you, and we'll talk more about this in detail again in the next session when we talk about geometric sequences. What the other formula is telling you is common ratios are the latter term divided by the former term. In other words, you'll notice that in a geometric sequence, you keep multiplying by a certain number. So if you want to figure out what that number is, just divide the latter by the former. Whereas in a common difference, you'll notice that you keep adding or subtracting the same number. So your way of figuring that out is to do latter minus the former, right? So what's important is what's really happening between the latter and the former. All right. Now, moving forward, then comes something called the nth term formula. The nth term formula, likewise, is for geometric as well as for arithmetic. And when you're using the nth term formula, you basically, if you were coming into a test in class, right, you would have had to memorize these, right? So these right here, you would have had to memorize them. And now you'll just kind of have them at your disposal as you're taking your take-home test, right? So that first formula right there says take a sub 1, i.e. the first term, and add to it n minus 1 multiplied by the common difference. And where exactly is the common difference? The common difference is right here. You basically find that first, and you plug that in, all right? More to this, recall that n stands for that certain term that you're interested in. So this is a formula that will help you find any term that you want. Okay, you can find any term in, as long as it's an arithmetic sequence, using the formula that you have established here. For a geometric sequence, it's very similar, except because geometric sequences are the multiplication of terms. So it basically says take a sub 1, all right, a sub 1, the first term, and multiply it to the common ratio. Now, what is the common ratio? The common ratio is merely a number, and that number is going to show up right here, okay? And that number is to the power of n minus 1. So notice the similarities, so that some of the differences, you know, in the arithmetic formula, you had an n minus 1. In the geometric formula, you also have a n minus 1. But it's a matter of how you're using the n minus 1, okay? And then furthermore, there is a sums formula. We'll talk about the sums formula. It's not worth writing them down right now because it's further down in the lesson where we need these. So we'll talk about the arithmetic sum and the geometric sum. But basically, this will give you the sum of all the terms. Okay, it'll give you the sum of all terms for both of these type of sequences. All right, and more on that inshallah in detail later. Okay, let's go ahead and then get started inshallah. The first question that I would like to try today is question number Bismillah 12. Okay, and the instructions say that you basically need to show that each sequence is arithmetic, and then once you've done that, find the common difference and write out the first 4 terms. Okay, so this is going to help you understand what exactly is an arithmetic sequence as well. Okay, so let's go ahead and start writing down. The beginning of this lesson is very similar to the previous lesson, where things were looking quite simple and easy, and then it kind of becomes a little bit more difficult towards the end, right? So t sub n is 2 over 3 plus n over 4. So I'm going to go ahead and find t sub 1. So 2 over 3 plus 1 over 4. And if you want, you can turn this into a common denominator. You can turn it into a decimal. I'm just going to work with fractions here. So I'm going to multiply 3. I'm going to multiply 4 like this. So I'll end up with 8 and 3, which is 11. So I end up with 11 over 12 for my first answer, all right? Moving on to the second term, I'll have, Bismillah, 2 over 3 plus 2 over 4. And again, the common denominator is a 12. So I'm going to multiply as I did before. I have 8 and I have 6, which is 14. So I end up with 14 over 12, all right? Now, remember, these are built on a pattern, so as soon as you can figure out a pattern, you probably don't need to keep doing this common denominator stuff, because this takes forever, right? Now, 2 over 3 plus 3 over 4, again, multiply this one by 4, this by 3, and this time we have 8 plus 9, which is 17 over 12. Can you tell the pattern, all right? Can you tell the pattern? Notice that we had 11 over 12, 14 over 12, 17 over 12. What do you figure the fourth term, without you doing much calculation, is going to be? It's going to be 20 over 12, right? One thing I will remind you of is, I know we're just at a very high level of mathematics here, where sometimes you have to not do certain things that you would conventionally have done. Like, for instance, that one proof that I gave to you, I'm sure you were entertained by that previous proof in the last lesson, which for me, even it took me like a while to finish that proof. I think I initially started with it and I struggled with it. So, what I mean to say here is, notice that you really are aching to simplify 14 over 12 and simplify 20 over 12. I give you one advice. In sequences, don't simplify. Okay, don't simplify. It will not allow you, it'll not allow, I don't want to say not allow you, but it'll hinder you from realizing what the pattern is, right? And so finally, the fifth term is going to have, Bismillah, 23 over 12. So we basically keep adding 3's in the numerator, right? Now, let's go ahead and write these out. All right, we've got 11 over 12. We've got 14 over 12. We've got 17 over 12. And again, if you want, you can go ahead and plug in those specific numbers into the fourth and the fifth term. By all means, you'll find that what I'm saying is true. You do end up with 20 over 12 and 23 over 12. So there you go. We've fulfilled what they were asking for us. Is we have written out the first, oops, sorry, it only wanted the first four terms. Well, we have the five. I don't want to erase anything now, right? So we wrote out the first five terms. And now what we're going to do is we're going to take these two right here, all right? And we're going to take the latter and subtract by the former, okay? In other words, we're taking a sub 2 and we're subtracting a sub 1. Now, figure out what do you get when you do something like that, and the answer that you get is 3 over 12. Okay, so you don't have to make any conclusions so far. Okay, now take a sub 3 and subtract a sub 2. All right, so a sub 3 subtract a sub 2. What do you get? You get 3 over 12. And you're welcome to try one more time. A sub 4 minus a sub 3, you get 3 over 12. And some of you might say, wait, weren't we using that exact logic to move it forward? Exactly. Okay, so in the beginning, this is quite straightforward. You'll have seen it before you've even established the answer. And so guess what? The common difference is therefore 3 over 12. And now you may simplify it if you wish. So the common difference is 1/4. And because it has a common difference, this must be an arithmetic sequence. You have proven it. All right, this is arithmetic. That's the very definition of a arithmetic sequence, is you basically keep adding the same amount as you go from one term to the next term. You're adding the same amount every single time. Okay, so that's number 12. And I want to try one more with you just really quickly, which is number 14. Number 14, it only looks kind of weird. It looks kind of confusing. It's really nothing. So let's write number 14 over here. Number 14 says that you have s sub n is equal to e to the power natural log of n. All right. First thing I'll remind you of is recall from logarithms that if you have a e followed by a natural log, what does that do? It actually just crosses them off, and you could have just written that s sub n is equal to n. But I won't do that. Okay, I won't do that. I'm just going to pretend like I didn't know any of that stuff. Okay, so let's go ahead and start writing out some terms. Now, I'm going to avoid writing like this. Okay, that takes forever. I know that based on the last lesson that you must have understood this by now. So I'm just going to go ahead and write it like this. E to the power natural log of 1, comma, e to the power natural log of 2, e to the power natural log of 3, e to the power natural log of 4. So there you go. I got my first 4 terms. And now you want to prove that, in fact, this is a arithmetic sequence. Now, how do you do that? You got to take these two terms, a sub 2 minus a sub 1, and you got to subtract them. So e natural log 2 minus e natural log 1 is going to give you 2 minus 1. And 2 minus 1 gives you 1. Now, let's take the next two. E sub 3 minus e sub 2 is going to give you 3 minus 2. And what do you get? You end up with 1 again, right? And then you may do that same thing for the last 2 terms that we have written here. And again, you'll come to the conclusion that this becomes 4 minus 3, which is also going to give you 1. Well, we've proven it. This has a common ratio, a common difference, and the common difference is basically a 1. Okay, it's actually just a 1. And so you can say that this is a arithmetic sequence. All right, so that's the first objective that we have, is to be able to realize that this is an arithmetic sequence. And again, somebody asks you, what's an arithmetic sequence? Very simple. Just tell them you keep adding or subtracting the same number. That's it. All right, and that number is called the common difference. Now, the next objective, it's a little bit different. It says find the nth term of the arithmetic sequence. So now we're going to be using the formula that we had talked about earlier. So you'll find me writing this down again and again, right? So we're going to be using the information they give us, and then you'll discover what that formula is all about. So we're going to be using the nth term formula as we go through this, inshallah, this exercise. And another thing that you want to take a look at is they talk about a common difference as well. All right, they talk about common difference, and you need to then, at the end, after you figure out an nth term formula, then you need to find the 51st term. So that's an additional problem that they're asking you. Okay, well, let's go ahead and get started. So let's try number 20. All right, try number 20. I know you're probably thinking, why do you keep picking the ones with the fractions? I honestly think that this subject is too easy for your class if I pick only the integers. So, have some fun with fractions while you can, right? So, first off, what we're going to do is we're going to write down the nth term formula. Okay, don't start till you don't have the nth term formula. So the nth term formula for a arithmetic sequence is a sub n is equal to the first term added to n minus 1 multiplied by the common difference. Okay, now we're ready to write down the nth term formula, and so you write down a sub n is equal to the first term. Now, what was the first term? The first term was 1, right? So I'm going to write down 1. And then it's followed by n minus 1 multiplied by the common difference. And the common difference is negative 1/3. So you can go ahead and put a negative 1/3 over here. I know that's a little bit awkwardly written, so if you wish, you are welcome to write it as 1 plus negative 1/3 times n minus 1. That's the same exact expression. All right? Now, sometimes what happens is the book will ask you, or the question will ask you to make this into something that's a little bit more expanded. And so in that case, you may use the distributive property and write down that this is the same thing as 1 minus 1/3 n plus 1, which is the same thing as 1 plus 1, which gives you 2. So 2 minus 1/3 of n. All right, so this is a final expression for the nth term. Now, what does that mean? That means I don't need to sit there and what you've been doing so far is writing t sub 1, t sub 2, t sub 3, t sub 4. Now I have an nth term formula, right? I know the pattern and I know the formula. If you recall from that previous lesson, let me find that previous lesson. In that previous lesson, recall how difficult it was for us to figure out those patterns. Remember where we did those pattern problems to figure out what the pattern is? That was very, very challenging to figure out, right? Well, in this situation, they're already telling you as soon as you know it's arithmetic, no reason to find the pattern. Just we'll give you the formula for it, right? So this is the formula right here. Now, what we're going to do here is we're going to use this to find the 51st term, right? And one of the reasons why they use the 51st term is because if you really understand what's going on here, what you'll do is you'll just start counting by the common difference. Keep going, keep going. Eventually, you'll hit that pattern and you'll get to the 51st term. And in fact, I've even seen kids do this, is they'll be like, okay, 1, and then I'm going to subtract 1/3 from it and write down 2/3. And I'm going to subtract 1/3 from that, and I'm going to write down 1/3 like this. And they actually attempt to go the whole way. Please don't do that, right? I mean, there's a reason why there's an nth term formula. It's to help you not have to do all that stuff, right? So here goes. 2 minus 1/3 of 51 is equal to 2 minus, Bismillah, I believe 51 divided by 3 is 17. I may be wrong, but you guys can check it as you're watching the lecture. And so the answer is negative 15. So the 51st term is negative 15. All right. All right, let's go to another question, and number 22. Number 22 looks, again, it just seems kind of difficult, but it's not. All right, so you have a sub n is equal to a sub 1 plus n minus 1 times d. And what you're going to do is you're going to put in the first term, and then you're going to plug in n minus 1, and then you're going to plug in pi. And therefore, a sub n, when you simplify it, simply becomes pi times n, pi times 1, so it becomes n pi minus pi. And this is your nth term formula. All right, that's your nth term formula right there. Now, if you would like to find the 51st term, that's not much more effort. You just do 51 pi minus pi, and you can actually simplify that a little bit, and you end up with 50 pi, and you're done. Okay? All right, let's move to the next objective, and the next objective is for you to really work with the same exact idea, but what makes the problem a little bit more difficult is the fact that they don't give you all of the nice things that they gave you in that previous set of problems. In the previous set, they just gave you the first term and they gave you the common difference, so it didn't need to get that difficult. Now, the problem is you don't have necessarily the first term and the common difference. Think of it this way. Back when we learned lines and you learned about mx plus b, the easiest question to do was when your teacher gave you the slope and they gave you the intercept. You're like, oh, sweet, this is working for me. By the way, while we're talking about this, mx plus b and the arithmetic sequence have a very striking similarity, right? The b is really the a sub 1, and the m is really that, bismillah, that n minus 1, okay? So it's interesting. Sorry, the m, I think, is actually the common difference, so it's d, right? Anyway, so back to what I was saying is, it was easy back then when, you were given the m and you were given the b, and you were like, okay, I can make this, no sweat, right? That was the question every kid would get right. But now the problem is you don't know everything about these sequences here, right? So I'm going to go ahead and take question number 26, and we'll go ahead and give that a shot. Number 26 says that your job is to find the 80th term. First, understand the question. You need to find the 80th term, okay? Now, here's what I would really suggest you not do, okay? Because some of us, we throw in the towel and we're like, okay, I'm going to go ahead and just it's like somebody saying, you know what, I know how to swim, so I'm going to go ahead and try swimming across the ocean. It's not going to work, right? So you could technically say this is the first term, this is the second term, and now I'm going to go ahead and figure out the 80th term, right? Please don't try that strategy. I have seen it, students do it as a last-ditch effort. It does not work for them, okay? So a sub 80 is what we're trying to figure out. They're telling us this is for sure an arithmetic sequence. So the first thing that you got to do is you got to realize that there is no way to find the formula or the term until and unless you don't set up the formula and get the components of it. So what we need is we need a sub 1 and we need the common difference. Think of mx plus b. You need m and you need b to actually move forward with it, right? So looking at the clues that they gave us, they told us 5, 0, negative 5. Guess what? We can figure out something from it. We can figure out the first term. The first term is a 5, right? So that wasn't so bad. All right, so let's keep moving. Then we've got plus n minus 1. And now what we got to do is we got to somehow figure out the common difference, okay? So here is a neat little trick to find the common difference. If you've understood arithmetic sequences so far, you're not really going to struggle with this. Basically, either take the latter minus the former here, or the latter minus the former here. What's the common difference? And the common difference that you end up with is 0 minus 5 is negative 5, or negative 5 minus 0 is also negative 5. So the common difference here is negative 5. See how I did that? Okay. Simplify this formula a little bit before you plug in for the term that you want. You don't have to, by the way, simplify. It just looks a lot neater if you simplify before you plug into the formula. So this becomes minus 5n plus 5, which becomes 10 minus 5n. Okay? Now, with that in mind, you can go ahead and find a sub 80. A sub 80 is simply 10 minus 5 times 80, right? So you end up with 10 minus 400, and therefore you end up with a negative 390. So based upon this pattern, by the time you get to the 80th term, you are guaranteed to get the number negative 390. Okay? So that is yet another objective of the lesson, and it's just basically using certain different pieces of information, but to get to the same exact goal. Okay, now what we're going to do is we're going to try something a little bit different. And in this case, what you basically have is you've been given two different terms within an arithmetic sequence. Okay, so instead of giving you that first term and the common difference, they're giving you just two random terms. And your job is going to be the following. There's quite a bit of different stuff you have to do here. First, you got to find the first term. So notice how that's none of it is easy because you have to figure out where you are and then figure out how many units you have to move. So first, you're going to find out the first term. Then you're going to find out the common difference. Okay, so you're going to have to do that first. Number two, you're going to have to give a recursive formula. If you forgot what a recursive formula is, in the previous lecture I told you a recursive formula basically tells you if you want to get the new term, how does that refer to the old term, right? So how does a sub n refer back to a sub n minus 1? What's the pattern there? So that's objective number two. Then the third thing that we're going to do is we're going to write down the formula for the nth term, and that's what we had in this formula sheet over here, the nth term formula. Okay, so plenty of stuff happening here. So what we're going to do is we're going to take, inshallah, one of these questions, and I'll take number 34. All right, I'll take number 34, and we'll go ahead and give it a shot. So here's what I have. In number 34, I've been given that the fifth term is -2. Very good. And I've been given that the 13th term is 30. Now, neither do I know the first term, nor do I know the common difference, right? Without both of these, I'm kind of stuck because then I apologize, then I cannot make a nth term formula, nor can I make a recursive formula, all right? So what are we going to do here, right? How are we going to figure out what the first term is? And I would recommend to you that you don't try counting forward and backward and stuff like that. That just makes things ridiculous. But what I will do is I'm going to give you just a thought, all right? Something to think about. So let's do it this way. I know that I'm at my fifth term. Okay, I'm at my fifth term. Here's my fifth term, right? Sixth term, seventh term, eighth, ninth, 10th, 11th, 12th, and by the time I get here, I'm at my 13th term, which is 30. Now you might be saying, wait, I thought you just told us not to do that. I'm only trying to demonstrate to you what I'm about to do next makes sense. That's the only reason why, okay? So if you think about it, there is some number, right, that you must keep adding to the previous number, and that keeps moving this train forward. So that by the time you get to this final number, you have managed to figure out what exactly that final term is, which is a 30, right? So if you count the number of times that you jump, right? 1, 2, 3, 4, 5, 6, 7, and 8, right? So what I tell students is think of it this way. The number of jumps, right, or the number of times you skip between spaces is 8, right? So what we'll do is we'll do a little trick here. It's really this same exact formula, just restructured, okay? What we're saying is a sub 13 subtract a sub 5, okay? We'll take a sub 13 and we'll subtract a sub 5 and we'll divide it by the number of times that we jumped. That'll give us the common difference, okay? So let's go ahead and try this. A sub 13 is the number 30. A sub 5 is the number -2. So look at that. 30 minus -2 actually is going to give you positive 32. Divide it by 8 and you end up with an answer of 32 divided by 8, which is 4. And so this right here is our common difference. If you don't believe me, you are welcome to keep adding 4. Keep adding 4, and by the time you get to the end, you will have reached 30, all right? Now, I've got something working for me. I know my common difference, So I can put that in. My common difference is the 4, right? But then I need to still figure out what is the first term, because without the first term, I can't figure out what this piece right here is. Again, it's just using the same formula in a reformatted version. So here's what I'll say. I'll say first off, a sub 13 is technically a sub 1 plus 13 minus 1 times the common difference, which I just found to be 4. Right? That's true because I've simply used this formula, and so it makes sense. Now, do I know a sub 13? Yes, I do. I know a sub 13 is the number 30. So 30 is equal to the first term. Now, this is what I don't know, right? This is what I don't know. So I'm using this formula to work to my benefit so I can figure that part out. And this is 12 times 4. So solve this little equation and you'll have figured out the first term. So this right here, Bismillah, gives us 48, and subtract 48 on both sides, and you end up with negative 18. And so the first term that we started off with must have been negative 18. Please realize it's not negative 2. That was the fifth term. So now we've got two pieces of information. We've got not only the common difference, we've also got the first term working for us as well. All right. Now the next thing that the question asked us to do was to form the recursive formula. But before we do the recursive formula, why not just write down the nth term formula, because we essentially have it manufactured. It always puzzles me why the book asks the question in such an odd manner in this lesson, but even though it's generally a very good book. So you could say negative 18 added to n minus 1 multiplied by 4, and that negative 18 and that 4, they're never going to change. So think of it like mx plus b. The m and the b never change. So in that same sense, we are done with this formula here. Okay. Now let's make a recursive formula. All right. Let's make a recursive formula. I personally think the recursive is a little bit easier. All right. Recursive. I don't write this word much. So here is the recursive way of looking at it. And what the recursive basically says is if you had a certain term, what would you add or subtract to it to get to the next one? All right. So for instance, if you had a sub 13, right? How is a sub 13 related to a sub 12? How could you go from 13 back to 12? Think of it that way. All right. So if you've understood this idea, why don't we take a moment and plug in all the numbers, okay, just to convince you a little bit. So negative 2 add 4 gives you 2. 2 add 4 gives you 6. So basically count out by 4. So 10, 14, 18, 22, 26, and like I guaranteed you, it would be 30, right? So how would you relate 26 and 30? If you were at 30, how could you go back to 26? Well, you could simply subtract from the from a sub 13. You could simply subtract the previous the number 4, and you could go back to 26. So, well, now if you wanted to go forward, all you would say is take that previous term and add 4 to it. So in a recursive formula, you're not allowed to put 13s and 12. You need to leave everything in n's as you did in the nth term formula. So all you have to say is that the next term is equal to the former term add 4. That's it. All right. It's the notation that gets people like, wait, what's going on with the notation? A sub n is the current term, and a sub n minus 1 is the former term. And if you want to call a sub n plus 1, that would be the latter term. Okay? So if you're sitting in a spot, okay, if you're sitting in a spot and you're telling me this is a sub n, well, the one that's before it is a sub n minus 1, and the one that's after it is a sub n plus 1. Please don't get confused by those notations, right? Just plug in a number. It'll make a lot more sense, like a sub 5, a sub 6, and a sub 4. It just makes a whole lot of sense if you just think of it that way, okay? one of the last things that we learn in this lesson, the lesson's not quite over yet, but one of the last main things that we learn in this lesson is to find the sum of a arithmetic, all right, an arithmetic sequence. And as you can see, the lesson is already at about 35 minutes, so that's one of the reasons why I had to split this lesson into 2 parts, right? For anybody, that would be too much to sit and listen to. All right, so we're going to be finding the sum, but before I begin with that, here's just a little motivation for you to think about. Let's suppose that somebody in our class, let's take Al-Rayan, it has a summer job, right? And in the first week of that summer job, let's suppose that Al-Rayan is making $120, right? He makes $120. And then we notice that in the second week, he makes $140. And in the third week, we notice that he makes $160. Right? So like this, if you were to write things out, you'd be like, well, he had 120, then 140, then 160. So anybody looking at this will be like, yeah, this is an arithmetic sequence. He keeps getting $20 more every single month based on this pattern. Okay? All right, now, please realize this is a sub 1. That's a sub 2. This is a sub 3. But what if I'm not interested in what he's making in a specific month? What if I'm the tax man and I'm more interested in how much he's making total, right? So this confuses students all the time, right? What exactly is S, right? S is the sum of all the terms up until that particular number that they're talking about, okay? So when I tell you S sub 1, that means add up the first term. Add up the first week of pay. That's just 1 week, so that's not going to be anything different than 120. But when I tell you S sub 2, that means add up the first 2 weeks and tell me what he got. 3, add up the first 3 weeks, like that. So the IRS, when it bills us, it wants S sub 12 in a sense of months. It wants to find out what you did every single month added up as a year, right? So the arithmetic sum formula, just be prepared for it. It's quite a handful, okay? I want to explain to you a few parts of it though. If there is one thing that goes in a formula sheet for you, it's this right here. All right, that is the sums formula. So you can pause the video and you can write that down, all right? But I'm going to continue here and I will show you where exactly did those other 2 versions of the same formula come about. Now, from trigonometry, you've gotten quite used to expecting things like this, right? Take a look at a sub n. Right above, and we've spent the last 30 minutes talking about this, right above, we have a formula for a sub n, right? We have a formula for it. So what we do is we simply substitute if we need to. We don't always have to. We can substitute for a sub n, and that is how I ended up with this secondary expression, right? That's the nth term formula. But if you give it some more thought, you'll realize that a sub 1 and a sub 1 gives you 2a sub 1. So then this formula is established in a different way. Now, if you're wondering why exactly would we even need something like that? Well, see, this first formula, when you've been given the n value, you've been given the first term's value, and you've been given the last term's value, that is going to work out for you. Okay, that formula is useful. The last formula, where is that useful? When you've been given the n, when you've been given a sub 1, but this time, you don't know what the last term is, but what you do know is the common difference is d. So in that situation, it really depends on what you've been given, but the swap out from a sub n to d is where you would use that secondary version of the formula. Okay, so we'll come back to it and see how it works in a moment. But number 46 is what we have to do. All right, so number 46, it basically gives you a certain number of terms here, And notice that now they're being added and subtracted and stuff like that. Now this is arithmetic. I know it's not written anywhere, but this is from the lesson of arithmetic, so we assume that this is an arithmetic sequence. Okay, you have to know that from before, but we assume this is arithmetic sequence. Now let's verify that, because this is still a new lesson for you. Just verify that. Remember, in an arithmetic sequence, whenever you take any two terms, all right, any two terms, notice that we don't know what happens over here. If you take any two terms and you subtract the latter minus the former, right, you should get the same exact number. So if you're doing number 46, you'll realize that 1 minus 7, 1 minus 7 gives you a negative 6. And you may verify that by saying, okay, what's negative 5 minus 1? That's negative 6. What's negative 11 minus negative 5? That's negative 6 again, right? So the common difference is certainly negative 6. But I know a little bit more. I know that the first term is actually 7. So I know a sub 1 is equal to 7. All right? All right, we know a little bit more. We know that the last term, right? We know that the last term that is in this sequence here is going to be negative 299. Now, if you've been following along, you're going to notice that there's a problem here. What's the problem? I don't know what term number is this. I don't know what term number is that. Like, for instance, let's suppose we were in a big lecture hall, right? And I ask you, right? I ask you, is so-and-so here, right? Is so-and-so in the lecture hall? And now this lecture hall has 1,000 chairs, right? It's an auditorium. And I say, is so-and-so here? And you say, yeah, that person's here. What's the next question I'm going to ask? Where are they? Right? So the problem is not that there is a negative 299. The problem is we don't know how far along the way did this negative 299 actually occur. And so that becomes the bit of dilemma that we deal with. Because if we don't know what that negative 299 is, what don't we know? We don't know n, right? We don't know n because n is supposed to be over there. If we don't know that last term, how exactly are we going to use any of the formulas that we had established? Whether you're working with a common difference or you're working with a sub n, you don't have enough information to proceed, right? So what we need to do is we need to pause a little bit and say, look, how about this? Let's write down the nth term formula. This is a very powerful formula, okay? So the nth term formula, it's used in financial sectors, it's used in many things, all right? Now, I know that the first term is what, right? I know that the first term is a 7. So I write that down. I don't know what the term number is for the last term, but I do know that the last term is negative 299. So again, I don't know what the term number is for the last term, but I do know that the last term is negative 299. So I plugged in for the last term, and the last term is negative 299. I knew that, right? I just don't know what its n value is. But look at what I've managed to do, though. Because I know that the common difference is negative 6, this formula can be restructured to actually tell us what term number that is. See how powerful it is. You don't have to count off by negative 6s and be crazy about it, right? So let's go ahead and solve this little equation here. So 7 minus 6n plus 6 is equal to negative 299 is equal to 13 minus 6n. Now, subtract 13 on both sides, and you end up with negative 312 is equal to negative 6n. And there you go. Now you can actually divide by negative 6, and I believe the answer should be 52. So you know that this is the 52nd term. Negative 299 was the 52nd term. Now imagine having to count back that whole way, right? So refrain from it, as I've told you several times now, all right? Now we are ready to use the sums formula. The sums formula says S sub n is equal to n divided by 2 multiplied by a sub 1 plus a sub n, right? So that's what the nth term formula is if we simply use its first version, and that's sufficient. You don't need to use the secondary version of it. It'll still get you the same answer. And so here is what we have. S sub 52. Look, now I know what term that number is, so I'm going to put 52, and what's going to happen is this number will also become 52. See that, right? The first term was 7, and the last term was negative 299. So 52 divided by 2 is 26, and then 7 added to negative 299 is negative 292. Now you can go ahead and multiply these two numbers in your calculator, and that number represents the sum of the first 52 terms. So this is less of a person making money. This is more of a person going into debt, and we're asking you, what is that debt after all? Now, all of these questions, essentially the ones that I'm assigning to you, work on that same structure. Okay, so by all means, sit down and try the homework, and inshallah you'll figure it out. You don't need me to do another one of these problems. Okay, it'll just basically just follow the pattern that I went through here, and inshallah you'll be able to figure out how to do it. Now we're going to try an application question, and remember, application questions are not necessarily new forms of learning. It's just you're applying what you learned already. Okay, so there's not necessarily an objective. This is just something that you have to be able to do, and sometimes for us this is the hardest thing to do, right? So it says, tell us what x that is. No guessing here, please. Okay, no guessing. We're trying to learn math, so no guessing. Find x so that 2x, then 3x plus 2, then 5x plus 3 are consecutive terms of an arithmetic sequence. If you don't understand what consecutive means, like 3, 5, 7, I hope I didn't just tell you the numbers. I don't think that can be 3, 5, and 7. But those are consecutive terms of an arithmetic sequence, right? They come one after another, and the common difference is clearly a 2 here, all right? So let's go ahead and set this up. So what I'm going to do is I'm going to write down 2x, comma, 3x plus 2, and then comma, 5x plus 3. Okay, now what do I have here? I have my first term, I have my second term, and I have my third term. What do you need to set up an nth term formula? Once again, you need the first term, and you need the common difference, right? N, it just changes based upon the term that you're on. So I actually have the first term here. The first term is the 2x, right? So I can plug in 2x for this right here. But more than that, I can actually figure out what d is by using a little bit of polynomial subtraction. So if I take 3x plus 2 and I subtract 2x, right? The idea of a sub 2 minus a sub 1 is just being moved forward. Well, I'll end up with x plus 2. And what that means is if I had done these other two, 5x plus 3, subtract 3x plus 2, guess what? I would still end up with, don't forget that subtraction sign is going to cause everything to change, I still end up with x plus 2 as that common difference. So the common difference here is therefore x plus 2. All right? So now I know certain things about it, right? So I have a sub n is equal to 2x plus n minus 1 times x plus 2, which leaves us with what exactly is x going to be and what is n going to be. Now, this is your pick, all right? It's hard to explain application questions simply because, you know, it's something that your intellect kind of guides you in that direction. So think about it. If I said, how about let's use a sub 3. What would happen automatically is a sub 3 would cause that n to become a 3 minus 1, right? Which is still multiplied to x plus 2. But then again, I know what a sub 3 is. A sub 3 is 5x plus 3. So I know what term that is equal to 2x plus 2 times x plus 2. And so on this right end over here, 2 times x is 2x, 2 times 2 is 4. So you'll end up with 2x plus 2x plus 4, which is essentially 4x plus 4. And on this side, you have 5x plus 3. Now we subtract the 4x on both sides, and we get an x. And we subtract the 3 on both sides, and we end up with a 1. So the the value of x is 1. So now let's plug back into this, right? 2 times 1, comma, 3 times 1 plus 2, comma, 5 times 1 plus 3. Let's see what we get. 2, 5, and 8. You see that? And so we have figured out these terms consecutively, and we've also figured out what the value of x was, and clearly this is a arithmetic sequence that we're looking at. And the last question that we're going to do is an application question for sums. So it says, how many rows are in the corner section of a stadium containing 2,040 seats if the first row has 10 seats and each successive row has 4 additional seats? Okay, so basically a stadium section, it might be in a corner. I haven't gone to too many stadiums, but what I could tell you is you could have this first one is your row 1, right? And what they're saying is each row that comes after it is going to have more seats than the row before it, right? So row 2 will have 4 more seats than row 1 does. And then all the way up until some nth row, right? So row n, right? There's some nth row there. But what they're saying is altogether, if you were to take the sum of all of those seats that you have from the first row to the nth row, you know that there is 2,040 seats. So let me formally write that here. We know that S sub n is 2,040 seats. Again, we don't know how many rows there are, and that's probably where the question is going anyway, right? Now they say that the first row has 10 seats. What does that mean, right? Think about sequences, think about sums. What that stands for is a sub 1 is equal to 10, right? So the first row has 10 seats. But remember, we got to get to 2,040. That's going to be a lot, right? So each successive row is going to have 4 additional seats. So now you have this working for you, right? So we got a lot here. We know that we're starting off with 10 and we're increasing it by 4 each. So 14 and then 18 and then 22 ... By the way, it's not asking you to get to 2,040. This is a common mistake students make, is they think that it's telling you to keep counting up until you get to 2040. That's not what it's saying. It's saying that when you go to a certain number, that once you get to that number and you add up all the numbers before it, you're going to end up with 2040, right? So it's kind of like saying, how many months are you going to have to work until you become a millionaire, right? So it's kind of like that idea is you have a sum in mind. You got to figure out, based on my work and stuff like that, how long is it going to take? And I just tell you a little side note, when it comes to financial organizations and stuff like that, and people planning for retirement, subhanAllah, this is basically what they sit there and they do. They run through this math, if that's something that's interesting to you, right? All right, now here's what we have. We have the formula for the sum of the nth term in arithmetic sequences. Looks like n over 2 times a sub 1 plus a sub n, like that. All right, but then we had a secondary version of that formula, and we said that the secondary version of that formula is n divided by 2 multiplied by 2a sub 1 plus n minus 1 times d. And we basically said this is just a reformatted version of the same formula, using the nth term formula in its place of a sub n. Okay, so let's go ahead and plug in to the spots that we have. All right, remember the question is asking you what is n. That's what you're trying to figure out, right? How many rows are you going to need in the end? And so the number of rows is represented by n in this situation. Well, here's all the things we know already. We know that S sub n is 2040, okay? We know nothing about n, and therefore n divided by 2 has to remain the way it is. So we're kind of stuck with that guy. Then we have 2 times a sub 1, which is going to be 2 times 10. Then again, we don't know what n minus 1 is, so n minus 1 stays, but we do know that the common difference is 4, so we have that. So we're going to basically be solving this question over here, and let's simplify it before we do something like that. We'll have n over 2, 20 plus 4n minus 4. 2040 is equal to n over 2, 16 plus 4n, like this. Now we got to get rid of this 2, and a good idea is to just multiply it on both sides. So 4080 is equal to n times 16 plus 4n. So we're just moving right along here. It's not difficult math. I'm just taking extra steps to avoid any mistakes here. So n times 16 is 16n, and n times 4n is 4n squared. So it's looking a whole lot like it's a quadratic formula. And so let's bring the 4080 over, so it becomes 4n squared plus 16n minus 4080, and it's equal to 0. Now before we start solving this, I would probably recommend that you divide everything by 4, because notice that all of these are factorable by 4, and if you can do that, it's going to actually help you in finding those two factors. Otherwise, use the quadratic formula, all right? So the two factors need to multiply to negative 120, and they need to, not negative 120, negative 1020, and they need to add up to a positive 4. You can pause and try to think of those two numbers. So the numbers that I get are 34 and negative 30. All right? So we'll have n plus 34, n minus 30 is equal to 0. And finally, solving for these, the first one gives you n is equal to negative 34. The second one gives you n is equal to 30. Everybody in the class knows that that wouldn't make sense to have a negative amount of rows. So there you go. We have the number of rows. In other words, by the time you get to that 30th row, by the time you get to row number 30, you will have accumulated 2,040 seats. All right, so we're already at an hour in this lesson, and we're only done with half of the lesson. So, inshallah, good luck on the homework, and I'll talk to you later, inshallah. Assalamu alaikum.